Introduction. Hello, and welcome to this lesson on functions and modular programming. Today, we'll talk about how functions can help you write cleaner, more efficient, and easier to manage code. We'll also explore how modular programming and error handling make your programs more reliable, especially as they grow larger. Functions are like little machines in your code. They perform specific tasks. You can run them as many times as you need without rewriting the same instructions. This saves you time, prevents mistakes, and helps keep everything organized. Throughout this lesson, we'll cover 4 main ideas. First, we'll look at what functions are and how they work. Then we'll explore how you give them inputs and get outputs. After that, we'll talk about how functions fit into modular programming, which means breaking your code into separate parts. Finally, we'll learn how to handle errors and fix problems in your code. By the end of this lesson, you'll be comfortable writing your own functions, organizing your code into small pieces, and handling errors that might occur. Understanding functions. A function is a set of instructions that performs a specific task. Instead of writing the same lines over and over again, you can write them once in a function and use that function wherever you need it. To create a function in Python, you use the word def followed by a name for your function. After that, you use parentheses. Sometimes you'll include inputs, which we call parameters. Then you add a colon and indent the next lines. These indented lines are the instructions that make up the function. Once a function is defined, you can call it by using its name with parentheses. If it takes inputs, you put values inside the parentheses. For example, if you have a function that says hello to someone, you can call it and pass in their name. Using functions helps keep your code organized and makes it easy to change or fix parts later. It also means you don't have to copy and paste the same code many times. Parameters and return values. Functions can accept inputs. These inputs are called parameters. For example, if you write a function that calculates a sum, the 2 numbers you add are the parameters. You can also get results back from a function. To do this, you use something called a return value. When the function is finished running, it can return a result to be used somewhere else in your code. Let's say you write a function that takes 2 numbers and returns their product. You can then save that result in a variable, print it, or use it in another calculation. You can also return more than one thing at a time. For example, you could return both the sum and the product of 2 numbers. Having inputs and outputs makes functions much more flexible. You can use them in many situations without rewriting the code. Scope and lifetime of variables. Now, let's talk about where variables exist and how long they last. This is called scope. Variables created inside a function are called local variables. They only exist while the function is running. When the function finishes, these variables go away. This helps prevent conflicts between different parts of your code. Variables created outside of any function are called global variables. They can be used anywhere in your program. But you have to be careful. Changing a global variable inside a function can cause confusion. That's why it's often better to pass values into functions using parameters and get results using return values. To summarize, local variables stay inside the function, while global variables are available everywhere. Understanding this difference helps you avoid errors and write cleaner code. Code reusability and modular programming. Modular programming means breaking your program into small, manageable parts. Each part, or module, does one specific job. This makes your code easier to read, easier to fix, and easier to expand in the future. Functions are perfect for modular programming. They let you write each task once and reuse it many times. If you want to change how a task is done, you only have to update the function. You don't need to search your entire program for every place the task appears. This is especially helpful when you work on larger projects or with a team. Everyone can focus on their part of the code, knowing that other parts are handled by different functions. To keep your code organized, it's important to follow the single responsibility principle. This means each function should do just one thing. If a function is doing too many things, it's harder to test and harder to fix when something goes wrong. Also, give your functions clear names. If a function adds two numbers, call it something like add numbers instead of something vague like do math. You can also add a short description to explain what the function does. This makes it easier for other people and your future self to understand your code. Debugging and error handling. Even experienced programmers make mistakes. That's why debugging and error handling are essential parts of writing good code. Let's start with debugging. Debugging means finding and fixing problems in your code. There are three main kinds of errors. First, syntax errors. These happen when your code breaks the rules of the language. For example, maybe you forgot a colon or a parenthesis. Python will usually tell you about these errors and where to look. Second, runtime errors. These happen while the program is running. Maybe you try to divide by 0 or use a variable that doesn't exist. These errors will stop your program unless you handle them. Third, logical errors. These are the hardest to find. The program runs, but the result is wrong. You don't get an error message, so you have to figure out what went wrong by checking your logic. A good way to start debugging is to use print statements. Print out the values of your variables at different steps in your code. This can help you see where something unexpected happens. If you're using an editor like Visual Studio Code or PyCharm, you can also use a debugger. This tool lets you pause your code and go through it step by step. You can check values, skip lines, or run parts of the program one at a time. Another great tool is code review. Ask a friend or teammate to read your code. A fresh pair of eyes can often find problems you missed. Now, let's talk about error handling. Sometimes things go wrong even if your code is correct. Maybe a file doesn't exist. Maybe a user types in something invalid. You want your program to handle these cases without crashing. In Python, you can use something called a try and except block. You put the risky code inside the try part. If something goes wrong, the except part runs instead of stopping the program. This way, your program can show a helpful message or try something else. You can also use multiple except parts to handle different kinds of errors. For example, if you try to divide by 0, you can show one message. If you use the wrong type of input, you can show a different one. Finally, you can use something called finally. This is a block that always runs at the end, even if an error happened. It's useful for things like closing a file after you're done using it. Handling errors like this makes your programs more stable and friendly to users. Instead of crashing, they respond gracefully and let the user know what went wrong. Conclusion. Let's review what we've covered in this lesson. We started by learning what functions are. They're blocks of code that do specific jobs. You define them once and use them as many times as you need. We learned that functions can take inputs, which are called parameters. They can also return outputs. This makes them flexible and powerful. We discussed the idea of scope. Local variables live inside functions and disappear when the function is done. Global variables live everywhere but can cause problems if not used carefully. We also explored modular programming. By breaking your code into functions, you make it easier to manage. You follow the single responsibility principle so that each function does one thing well. You use clear names and descriptions so others can understand what your code does. Finally, we talked about debugging and error handling. Debugging helps you find and fix mistakes. Error handling helps your program respond to problems in a helpful way. You use try and except blocks to catch errors and keep your program from crashing. By using functions and modular programming, you can build better, cleaner, and more reliable programs. You'll be able to grow your projects more easily, fix problems faster, and work better with others. As you continue practicing, try writing your own functions. Start with simple ones that do small tasks. Then combine them to make bigger programs. Use print statements to debug. Use try and except to handle problems. The more you practice, the more natural these ideas will become. And soon, you'll be writing professional quality code that's not only correct, but also clear and easy to maintain. Thank you for listening to this lesson. I hope you feel more confident about using functions, organizing your code, and handling errors. Keep practicing, and happy coding!